Hi guys, this is for Algebra 1, Unit 2, solving linear equations and inequalities. So number one, we're starting off with trying to create a linear function or inequality from a verbal description. So Terry, all right, so Terry already caught 10 Pokemon and he catches 2 every day. All right, so I'm thinking this. I'm thinking Pokemon, all right, within a certain amount of days. That's time. All right, so Pokemon is the P, T is for time, for days. And Terry catches 2 per day, and he already has 10 Pokemon. So that would be a really good linear function for Terry's situation. So go ahead and try, let's see, go ahead and try part B. But just be aware, Sam has a certain amount of calories already, and he burns 2,000 every mile he jogs. Burns, does that mean he's adding 2,000 every mile? Or is he subtracting 2,000 calories from his 12,000? So that's my hint for part B. All right, so part C is a lot like A, so I think you guys can handle that one on your own. Let's see, part D, Gail shipped flowers. Each shipment costs $1.50. So if we go scrolling down a little bit, sorry. So $1.50 per shipment. Okay. But wants to spend at most $40. At most $40. Can she spend more than $40? No, it's got to be less than, right? But at most, can she spend exactly $40? Yeah, she could afford that. So that would be this following inequality here for Gail for each shipment for flowers. Okay. All right. So let's see. Part E is a lot like D. Just be aware of what numbers and where, and also pay attention to the wording for her goal. Okay, so that way you know what symbol to use correctly. All right, so here we are with Tam and Sari again. Terry and Sam. Ooh, getting mixed up. Terry and Sam collect Pokemon. Okay. Terry already has 10 Pokemon. Catches 2 per day, right? Or 2 every day. That we already did that guy, right? We did what was it? All right, 2T plus 10, right? And then Sam, he has 4 Pokemon, but he catches 4 every day. And then the question is at what day will Terry and Sam have the same amount of Pokemon? Well, we have to set them equal to each other. So let's go ahead and try that. We got Sam, right? And we're comparing him with Terry, right? And Sam, he catches 4 Pokemon per day, plus the 4 that he already has. Terry, on the other hand, was 2 Pokemon per day, and he already has 10. So basically they're saying, well, when are they going to have the same amount? So let's go ahead and solve for our variable. In this case, it's t for times because we're caring about how many days it takes. So let's see, what's the difference between their rates of Pokemon they catch? So let's use a subtraction property. Let me get that out of there. All right, so hopefully those cancel out, right? 4t minus 2t is 2t. The plus 4, we haven't dealt with that term yet. And the 10 is all by himself on the right-hand side. All right, so how do you get rid of a plus 4, right? Because we're trying to isolate the variable. So we have 2t plus 4 equaling 10. How do you get rid of a plus 4? Subtraction property, right? So we have 2t equaling 10 minus 6, or 10 minus 4, 6. How do you get rid of a multiplying 2? Division property of equality. What's half of 6? 3. So in 3 days, both of these guys will have the same amount of Pokemon. But how many, right? That's our second part of our question. Okay, how many Pokemon will they both have? We'll just plug back in what we got for T. And it doesn't matter which one you plug it back into. You could plug it in for Sam. All right, he was what, 4t plus 4? So if we do that for Sam, it's going to be 4 times 3, because t is 3, plus 4. So 4 times 3 is 12, and 12 plus 4, right, is 16. So that's 16 Pokemon. Okay. Now, if you did the same thing with Terry, Terry would have been, or should have been, the same result, except Terry is what, 2t plus 10? And if you plugged in 3 for t, you should get the same thing. We got 2 times 3, which is 6, and 6 plus 10, also 16. So be aware that if you did this correctly, you should have the same amount of Pokemon for both people. All right, so that was part 1 of the question here, and how many days, and then part 2 was how many. So in sentence form, you could always write in 3 days, comma, both Sam and Terry have 16 Pokemon. All right, so that would be the ideal answer, or the way to state it. All right, so number 3 is very similar, okay, to Sam and Terry. So go ahead and try that one on your own. Number 4, solve the following equation. So again, we're trying to isolate our variable, which is x. And, well, we have a term that doesn't have an x on the left-hand side, minus 3, right, or negative 3. How do you get rid of a negative 3? Plus 3, right? But just remember what you do to one side, got to do to the other. So when you do that, these cancel out. You'll have x over 8 equaling negative 1. And then how do you get rid of a multiplying or a dividing 8? Multiply. But remember what you do to one side, do the other. So 8 divided by 8 is 1. And in this situation, oops, sorry, that didn't come out right. So we're multiplying here, and we're multiplying to the other side as well. There we go. So you're going to have x equaling, what's 8 times negative 1? Negative 8. And that would be our solution. You could always double check. Make sure you got it right. You plug in 8, or negative 8, right, for x. Negative 8 divided by 8, negative 1. Negative 1 minus 3, negative 4. And negative 4 doesn't equal negative 4. So that means you did it right. Okay, it's a great way to double check and make sure you got your answer. All right, part B. Go ahead and do that. It's very similar to part B. Okay, so how do you get rid of a negative 10 or a negative 8? What you do to one side, do the other. How do you get rid of a multiplying 10? What you do to one side, do the other. Go ahead and try C. C is very similar to A. And you can do part D several ways. Okay, but I want to make sure you guys get your practice for that. Try to do that one. It looks confusing, but if you remember something about how to handle those leading fractions, it could probably spare you some time. All right, number 5. So solve and graph the following inequalities. So what we're going to do here is go ahead and solve for x. Now, first things first, you could either distribute. Okay, so 2 times x is 2x. 2 times 1 is 2. You could have done that and then solve like normal, or you could have divided by 2 to both sides, and you would still get the same answer. So that's really up to you on what you're comfortable with. All right, so how do you get rid of a plus 2? Minus 2, right? So what we did here was we distributed distribution property. Right? And then we're going to use the subtraction property to get here. All right, almost done. How do we get rid of a multiplying 2? Divide, right? So we have x is greater than, what's half of 8? 4. So again, that was the division property that we just did. All right, so there is our solution. How do we graph that? Well, go to 4, and it's going to be a hollow point. Now, the reason why is because x can be greater than 4, but it can't be 4, okay? It's not an option. So 5, for example, 5 is definitely greater than 4, and so is all the other numbers going up. So that's why we draw our arrow, or shading region, this way, okay? Because everything else would be false. All these numbers are smaller than 4, not greater, okay? So that's why we don't shade there, including 4. 4 is, right, it's in reference to everything above 4, but it can't be at 4, so that's why it's hollow. All right, so go ahead and try part B. Do that one. Okay. Go ahead and actually, you know what? I'll do C. Remember, if we got to switch our symbols when we divide both sides by a negative. So we're going to see that example. So how do you get rid of a negative 10? Plus 10, right? What you do to one side, do the other. And let me scroll down here. There we go. All right, so that's the addition property. Got negative 5x. It's greater than or equal to 20. And again, that was the addition property. Now, how to get rid of a multiplying negative 5? Divide by a negative 5. But remember, what you do to one side, do the other. Now, when you divide by a negative to both sides, the symbol, again, flips. So you're going to flip that. So 20 divided by negative 5, negative 4. And that will be our solution. Negative 4 is right here. Now, the way you read this is x is less than or equal to negative 4. Notice the or equal. So it can be at negative 4. And then less than negative 4. So like negative 5, that would be true. So you would shade to the left. And again, it could be at negative 4, right? Less than or equal, right? So everything else is true going below. Everything else above negative 4 is false. So that's why we shadow there. So remember, flipping the inequality symbol when dividing both sides by a negative. So remember that idea. For example, you want $10 over $5, right? But if I negate both sides, so you owe me $10 or you owe me $5, you would rather owe me $5, right? So that's owe, and this is earn, right? So notice the difference when in the inequality when you negate both sides. Same concept. All right, so I'll do 6A. You guys definitely get B and C. Again, how do we get x all by himself? Well, we have a negative 3. How do we get rid of a negative 3? Plus, right? But remember, if it's written as a compound inequality, again, compound inequality, right? Compounds look like this. What you do on the inside, do to the outsides, okay? So we got 3 minus 2, or negative 2 plus 3, and that should get you 1. 1 is the loneliest number. All right, there we go. Come on, pen. There we go. And x is all by himself finally. 5 plus 3, it's 8. So this would be our solution for this problem. How do we graph that? Well, let's go to 1. X is greater than 1, right? But it's not at 1. Okay, so x is greater than 1. That means 2 is greater than 1, 3 is greater than 1. So I feel like we're going to be shading this way. Okay. 8, on the other hand, x is less than 8. Less than 8. So it can't be at 8, but it could be less than 8. So notice how these two statements start to overlap each other. Okay, so anything in between 1 and 8 will be true, but 1 and 8 themselves will be false, as is everything else outside of that area. Okay, so try part B and C. Notice how C is an or statement. So your graph is going to look something like this. So be aware of that. All right, 7a. So we're writing a compound inequality for this range, or we're graphing the solutions. Um, so we're writing the inequality. So altitude for a stratosphere, the altitude starts at 16 kilometers to 50 kilometers. Swell. So altitude for the stratosphere, we'll use distance, d, okay? And the distance of our stratosphere has to be greater or equal to 16 kilometers and less than or equal to 50 kilometers. So we go from 16, which is like right about here ish, okay, to 50. And then everything in between is the stratosphere. All right. And beyond that's the nanosphere. All right, here we go. So part B, go ahead and try that for yourself. Water is not liquid if its temperature is above, okay, 100 degrees or below. So think about that. It is an or statement. Okay, so it's definitely going to be looking like, not like that, sorry. It should be looking like this. Something like that, okay? All right, number 8. So you're gonna eventually take loans from a bank. In this situation, you're gonna cash out on 5,000 bucks for a loan. Your bank told you that the interest rate was 3%. All right, so we represent that with R. And again, your simple interest loan was for the principal amount of $5,000. But after the year interest, after 10 years, totaled 500 bucks. What? Okay, so that's weird. Was your interest rate 3%? So let's find out. Well, we have the interest, right? 5,000 bucks. We have, or we have the interest, 500 bucks, right? We have your principal, that's 5,000. We don't have your rate. We do have 10 years. So let's go ahead and rewrite this so we can go ahead and isolate our variable that we are trying to figure out, which is our interest rate. So how do we get rid of a multiplying p and a multiplying t so that we can isolate our variable, which is r, right? The one that we're trying to find. Hopefully you realized they're multiplying, so the opposite of multiplying by p and t is to divide by p and t. So that's how you would get r to be by themselves. So r really just equals your interest divided by your principal times your time. So we were checking if our rate was 3%. Well, let's find out. Our P was our principal. Let's see, our interest was 500 bucks. So the bank made 500 bucks, right? Our interest. Our principal, right? So again, I'm going off of that. Our principal was $5,000, and our time was 10 years. So let's go ahead and check for our rate. So 500 divided by 5,000. Don't forget that you're multiplying by 10 there. And you end up getting 0.01. Now, what does that mean? That means your interest rate was really at 1%. All right, which is awesome. It seems like your bank made a mistake or something, or they didn't catch the mistake, and you're getting lucky. All right, so hey, winning. So were you at 4%? No, but your rate, your interest rate, was at 1%. Not too bad, not too shabby. All right, so number 9, same situation. So go ahead and test the idea, isolate the variable that they're asking about, and see where your interest rate lies. All right, they said it was 6%. Were they lying? Um, did they make a mistake to where you're saving money, or did they lie to you and you're being charged more than 6%? So go ahead and try to figure that out. Same process as before. All right, so I'm gonna be honest. Number 10 is great. Number 11 and 12 is definitely meant for you guys. You guys got to practice this. All right, so isolating the variable v. All right, so we're gonna go ahead and try to get v all by himself. Now v has a dividing t with him, right? He also has a subtracting u. Division is more powerful than subtraction, right? Because you don't want people to divide you, but at the same time, you don't want people to take away from you. But people who divide you, those people are way more harmful. Okay, so we're going to take care of the dividing t because he's way more powerful and harmful. So what's the opposite of dividing by t? Hopefully you said multiply, right? Just remember what you do to one side, do the other, right? So what's really going to happen is a times t, or t times a, is going to be a t. The t's here cancel out, and all that's left is v minus the u, right? Now, how do you get rid of the subtracting u? Okay, plus u. But remember what you do to one side, do the other. So what you're really going to have is a times t plus that u equaling your v. And remember, symmetric property can still exist, so you might see an answer like this. Who knows? In the future, they might just rewrite it, but same thing. All right, that's a symmetric property. And again, we used multiplication property of equality. Then we just did the addition property of equality. Okay, so go ahead, practice number 11 and 12. And I think you guys are going to be just fine. If you have any questions, come see me. You guys have a couple days. All right, have a good one.